Did you know that beer is one of the oldest drinks produced by humans? Imagine stepping into a modern brewery. The warm smell of malt and hops in the air, giant stainless steel tanks humming quietly, and computers controlling every step of the process. Today, we are going behind the scenes to see how science and tradition work together to create beer. From simple grains to the final product you see on shelves. Stay with us as we follow the complete journey of beer manufacturing, step by step. The four basic ingredients. Beer is usually made from just four main ingredients: water, barley, hops, and yeast. Water makes up most of the beer. Its mineral content and purity have a huge impact on taste and mouthfeel. Some regions even became famous for their beer simply because of their water. Barley is a cereal grain that has been used in brewing for thousands of years. It is full of starches and enzymes. During the process, these starches are converted into sugars that yeast can later ferment into alcohol. Hops are the flowers of the hop plant. They are responsible for adding bitterness, flavor, and aroma to beer. The compounds inside hops, like alpha acids and essential oils, can create notes of pine, citrus, flowers, fruit, or herbs. Yeast is a living microorganism, a single-celled fungus. It is the engine of fermentation. Yeast consumes the sugars from the barley and produces alcohol and carbon dioxide, which give beer its alcohol content and natural fizz. These four ingredients may seem simple, but the way they are treated and combined creates the huge variety of beer styles around the world. Malting, preparing the barley. The first major step is called malting, and it transforms raw barley into malt. First comes steeping. Fully ripened barley grains are soaked in cold water for about 2 to 3 days. The water is changed regularly to keep the grains clean and to ensure they absorb enough moisture. Next is germination. After soaking, the grains are spread in shallow tanks or on germination floors. They start to sprout. During this phase, enzymes are activated inside the grain. These enzymes will later help convert starch into fermentable sugars. Then, germination is stopped by drying or roasting the grains in a kiln. Light roasting produces pale malt, used for lighter beers. Darker roasting develops deeper colors and richer flavors for darker beers. The final product of this stage is malt, dried, enzyme, active barley. Ready for the next step, milling and mashing, extracting the sugars. Now, the malted barley moves into the mashing stage. First, the malt is milled. It is crushed in special mills to form a coarse powder called grist. The aim is to break the grain enough to expose the inside, but keep some husk pieces intact. This helps later on in filtration. Then comes mashing. The grist is transferred into a large vessel called a mash tun. Hot water is added, creating a thick, porridge-like mixture called mash. The temperature is carefully controlled and usually passes through specific ranges so that enzymes in the malt can work efficiently. These enzymes break down the starches into simpler sugars. The balance of sugars created during mashing has a big influence on the body, sweetness, and potential alcohol content of the finished beer. After this, the mixture is moved to a tank where the liquid portion, now called wort, is separated from the solid grain. The grain bed itself acts as a natural filter. Hot water is sprayed over the grains in a process called sparging, rinsing out the remaining sugars. The result is a clear, sweet liquid. The wort, which will be boiled and flavored with hops. Boiling and hopping, building flavor and bitterness. The wort is now pumped into large boiling kettles, often made of stainless steel or traditional copper. During the boil, several important things happen. The wort is sterilized, killing unwanted microorganisms. Volatile compounds are driven off. The wort is concentrated, and its composition is adjusted. This is also when hops are added. Hops added early in the boil mainly contribute bitterness, as the alpha acids are transformed by the heat. Hops added later in the boil usually in the last 15 to 30 minutes, contribute more flavor and aroma, citrusy, floral, herbal, or piney notes, depending on the hop variety. The boiling process usually takes about 60 to 90 minutes. During this time, proteins in the wort clump together and are removed, helping to ensure a clearer final beer. Once boiling is complete, the hot wort is ready for cooling and fermentation, turning sugar into alcohol. The freshly boiled wort must be cooled quickly before yeast can be added. The hot wort passes through a heat exchanger where it is cooled down to a temperature suitable for fermentation. The exact temperature depends on the type of beer and yeast strain. The cooled wort is then transferred into large, sanitized fermentation tanks. Yeast is added, a step known as pitching. During primary fermentation, yeast begins feeding on the sugars in the wort. In the process, it produces alcohol and carbon dioxide. This stage usually lasts from 1 to 2 weeks, depending on the recipe and conditions. The temperature is carefully controlled, so the yeast works properly and the desired flavors are produced. Some beers then go through a secondary stage. The beer may be transferred to another tank or left to age longer in the same vessel. This allows flavors to mature, smooth out, and become more complex. Secondary fermentation and maturation can last from a few weeks to several months, depending on the style. Throughout fermentation, brewers monitor temperature, sugar levels, alcohol content, and flavor development. This careful control ensures that every batch matches the brewery's quality standards. Conditioning and clarification. After the main fermentation phases, beer is not quite ready yet. In the conditioning stage, the beer continues to develop its flavor. Remaining yeast and other particles settle to the bottom, and the beer becomes clearer and more stable. Some breweries may add a small amount of sugar or carbon dioxide to adjust carbonation levels. This can be done naturally in the container, or by directly injecting carbon dioxide. Conditioning helps create a smoother, more balanced beer with the right level of carbonation and clarity. Packaging, bottles, cans, and kegs. Now comes the final step inside the brewery. Packaging. Before packaging, many breweries filter or centrifuge the beer to remove remaining solids and yeast. This produces a stable, clear product that looks attractive in the glass. The level of carbonation is set precisely because it is an important part of beer's texture and mouthfeel. On a bottling line, thousands of bottles per hour can be washed and sanitized, filled with beer, and sealed with caps. A small space is left at the top of the bottle, and oxygen is minimized to maintain freshness. Cans offer excellent protection from light and are easy to transport. They are filled and sealed quickly to avoid exposure to air. Many craft breweries now use cans for quality and convenience. For draft beer, the product is filled into kegs. Kegs are pressurized with carbon dioxide to keep the beer fresh and carbonated. They are ideal for bars, restaurants, and events where beer is served on tap. Labels or prints are applied to each bottle, can, or keg. Beyond just information, the branding tells the story of the brewery and the beer style, helping consumers recognize their favorite products. Throughout this stage, quality checks are performed to ensure packaging is secure, carbonation is correct, and the beer tastes as it should. Distribution. From brewery to consumer. Once packaged, beer leaves the brewery and enters the distribution chain. It is moved to warehouses, where it is stored under the right temperature conditions to keep it fresh. Distributors receive orders from shops, bars, and restaurants. Advanced systems help manage stock and make sure the correct products are shipped. Beer is loaded onto trucks, often with temperature control, and delivered to retailers. At the store or bar, beer is again stored properly, often refrigerated, and stock is rotated, so the oldest products are sold first, keeping everything fresh. Finally, the beer reaches the consumer. Behind that one bottle, can, or glass is a long, carefully controlled process involving agriculture, biology, chemistry, engineering, logistics, and quality management, and that is the complete journey of beer manufacturing. From water, barley, hops, and yeast, to malting, mashing, boiling, fermentation, conditioning, packaging, and distribution. Next time you see a beer on a shelf or in a restaurant, you will know the complex science and craftsmanship behind it.